Hey, so this is part 2 of a mini-series that shows you how to build an AI home security system using .NET, Python, CLIP, semantic kernel and some other technologies. The main hardware involves a Raspberry Pi, passive infrared sensor and camera. In part 2 of the series we look at how to implement a image recognition or image classification component that forms the system. I do recommend reading part 1 before you dig into this, but in essence the high level requirements for the system are to perform motion detection, it captures a photo, and if the image belongs to a series of training data it will identify the person. If they're not in the safe list it will send a telegram message to a cell phone. Okay, and in particular to do this it uses a technology called CLIP. CLIP is an AI model developed by OpenAI, and it helps you generate vectors from incoming images. Okay, under the hood these vectors can then be compared against one another using cosine similarity. There is a link to check out what cosine similarity is and how it works, and you can see that there by the link, right? So you can take a look at this blog post. We cover how to implement the CLIP server using Python, which we can see here. And in essence what it does is the Python code exposes an API with an endpoint called embed, and you can attach an image and submit that to the API endpoint, at which point the embeddings get returned. Okay, so that's what we can see here. We've got the API running in Visual Studio Code, we've got a post request here being set up, we submit it and we get some vectors, right? So we can demo that just now. If we bring up Postman, and we can see we've got the Postman request set up here. And if we pull over Visual Studio Code, we can see that we've got our CLIP server running, right? So the code's pretty straightforward. There's an API endpoint called embed that expects the file parameter, and the CLIP model is loaded here at line 10 to perform the vectorization of the supplied image. And then down here at line 23 we see that the embeddings are returned back, right? And at line 27 we can see that it's running on localhost over port 5003. If we look down at the console we can see that it's running, it's started up. So we'll pull this back over here and we'll send the request via Postman. It will hit the endpoint of Visual Studio Code, so we can see here that it's just accepted another request. And then in Postman we can see the vector embeddings that represent the supplied image. So with the information in this format, we're then free to later on run evaluations against these vectors. And within the context of the home security system project, we will use these vectors to perform comparisons against training data and decide whether or not if the system should send an alert with an image to a Telegram bot, and consequently a cell phone. If you want to find out more information about how this works, you can review the accompanying blog at jamiemaguire.net and look in the description of this video. Thanks.